Right, so this is now, guys, question number, question 3. So first of all, part A, this is worth a total quite a lot of marks, 1, 2, 3, 6, 7 marks. And this time it says the table below shows data for reactants D and E. So we've got the concentration data for reactant D here, reactant E here, and there's my initial rate in moles dm to the minus second to the minus 1. So if we want to determine the order reaction with respect to this reactant, I would pick experiments 2 and 3. Why? Well, that is because the concentration of reactant E is constant, do you see? So whatever effect that has on D, whatever we do to D, that has an impact on the initial rate is primarily due to reactant D and not E because its concentrations are constant. And the first thing we note is what is 0.39 divided by 0.13? Well, that is times 3. You happy with that? Now this here is a good trick my physics teacher, Mr. Kemp, obviously told me. When the powers are the same, we don't need to waste time in a calculator. You could just do 2.34 divided by 0.26. Look how much time you save. But that trick only works when the powers, like in this case, is the same. And if we do 0.34 divided by 0.26, we end up with 9. Is that right? So this is times 9. Right, so what's the order? Too easy, second. How did I got that? Well, look what we've done. We've tripled the concentration of reactant D, and the rate has gone up 9 times. And what did I say for second order? 3 squared. There you go. It can't be first because you're going to. So this is too easy. You just put second order, or you could put the number 2, whatever makes you happy. Right, we're on to part B next. Now, part B is now we have a slight problem. And the problem you will notice is if we want to work out the order reaction with respect to reactant E, can you see any 2 experiments where the concentration of D is the same? No. So this is slightly trickier, but it's not the end of the world. Let's rub that out. Okay, we don't need that as well. Let me just rub that out. Okay, so what I find a lot of students ask me, what would you do? Okay, obviously we can't pick experiments 1 and 2. So the only way you're going to do this is either you pick the data experiments 1 and 3 or 2 and 3. Now I get this asked all the time. I say to students, I look at the numbers like 0.78 divided by that is not a very decent number, yeah? But that is a very nice number. Look at this. Can you see that? And if you check, am I right, is that times 2? Just do 0.78 divided by 0.39. Yeah. Good. And look at this. This is a no-brainer. This is also times 2. Okay, no-brainer. So what we've done in experiments 2 and 3, we've doubled the concentration of reactant D, and I've also doubled the concentration of reactant E. So what's happened to the rate? And again, the powers are the same. Can you do 9.36 divided by 2.34? So if you do that, I'll do it. 9.36 divided by 2.34. 4. Is that right? So this is times 4. Okay, now, right, so we already know from part A that the order reaction with respect to reactant D is second order. There's no doubt. So ignore that, and I want you to just tell me straight away, that means that if you double the concentration of reactant D, then 2 squared is 4. Am I right? So the rate should have gone up 4 times. And the rate has gone up 4 times. So this means by doubling the concentration of reactant E, has E had any effect on the initial rate? And the answer is no. Right, let me go through that one more time. So we know from part A, using experiments 1 and 2, that as we tripled the concentration of reactant D while E was constant, the rate went up 9 times. So what we deduced from that, no doubt, that the order reaction with respect to reactant D was second order. Right. Now, if you look at reactant 2 and 3, it's slightly more complicated, but it's not that we can't answer the question. Why is it complicated? Because what you're doing, you're changing the concentration of both of these reactants simultaneously. Got it? So what we've done here, we've doubled the concentration of D, and we've also doubled the concentration of E. Okay? And what we've found is that the rate has gone up by 4 times. Okay? So, because we already know order reaction with respect to reactant D is second order, then if you double the concentration of D, 2 squared is 4, as you can see just there. So this means that the rate should have gone up 4 times, and it has. And that means that has doubling the concentration of E made any effect? No. Now this is the point where I get asked a lot of questions from candidates, and you can also ask me these questions. Okay then, that's fine. You said it's 0. Okay, can you tell me how would that value change if this was first order? Yes, I can. It will be my pleasure. Because if this is first order E, just pretend, then this rate should have gone up by 6 times. Do you get what I'm saying? Why? Because if E is first order, if you double the concentration of E, the rate will also double. And if you think about it, times 4 plus times 2 is times 6. Make sense? And lastly, if pretend the concentration of E was second order like D, then if you double the concentration of E, the rate would have gone up 4 times along with that. And 4 times 4 and 4 is 8. So this means the rate should have gone up by 8 times. Now, is it 8 times? No. Is it 6 times? No. So that means clearly that changing the concentration of E has had no effect. So there's no doubt it is 0 order. Does that make clear? Yeah? Right, so that's that. So I get 2 marks already, 1 for this and 1 for that. Now it says use your answers to part A and B to determine the rate equation. Well, that's going to be quite easy. The rate equation, rate, will equal K, the concentration of D. And this is very good, and I like this example I've done, and that is simply because it goes into my theory concept. I told you if the concentration of reactant is 0 order, you must not include it in the rate equation. And so you leave the rate equation like that. So I get 1 mark for that. Then part D, calculate the rate constant and state its units. Okay, so I'll go for experiment data number 1, it's up to me. So rearrange K, the rate equation to get K the subject. K is rate divided by concentration of D. So the rate is 0.26 times 10 to the minus 3. And the value of the concentration reactant D is 0.13. We're not including that, remember, that's 0 order. So if we get our calculators out, work that out. So 0.26 0.26 EXP minus 3 divided by 0.13. Right, can you check this out? Is this right? Is it 2 times 10 to the minus 3? Double check that. Yeah, and the units we can do here, so it's moles, dm to the minus 3 seconds to the minus 1. You can always pinch them from there. And the units of concentration of D is just moles per dm. And this is a wonderful opportunity. Can you see it's the simplest unit you can get? I told you. So it's seconds to the minus 1. And usually on the exam paper there'll be a dotted line, there's a little space, and then there's a second dotted line. So the first dotted line you put the numerical value of K, the rate constant, and on the second line you put the units. And finally E, the easiest of the lot, calculate the overall order of the reaction. Well, the answer is 1. Because it's on its own, you see, there's no other thing, so it was just 1. Okay, so there goes another question.